2, 1.
Hello, everyone. Welcome to our 4th Azure DIY session. Today, we have got Bill Chesnut from SixPivot. He has been an MVP for almost like 16 years now on Microsoft services, and he's big on BizTalk. He has seen the journey from BizTalk to Azure using LogicApps, API management, and also Azure Functions. So in today's event, what we're going to do is we are trying to break, because it's a 1 hour slot, we're going to break it up into 2 different slots. So this week we are going to cover off Azure Functions and LogicApp, and we'll be doing some deep dive, hands-on demo around those ones. And in the next week's session, we are going to go deep into API management. Just a few quick things before we kick off. This session is recorded, and throughout the session, please feel free to send all your Q&As, all your questions in the Q&A section that you can see right now. And shoot as many as questions you want to, and we'll be happy to keep answering those ones. Now over to you, Bill.
Thank you very much, Cherie. Have we shared my screen yet?
Yeah, we have, Bill, so you're up and live.
Okay, thank you very much, everyone, for attending today. So basically, we will be going through some of the features of serverless. So let's go ahead and get started. A little bit about me, but I'll have that a little bit later on too if you people want to get in contact with me with additional questions and things like that after the session. The agenda for today is going to be kind of a introduction a little bit to serverless. Most people are probably familiar with that. Then we're going to have a introduction to LogicApps, introduction to Azure Functions. Then we'll look at implementing an API with both LogicApps and Functions, and then we'll look at building integrations with both LogicApps and Functions, and a little bit on how to choose. So what is serverless? If you look at the way that serverless is approached in Azure, you'll see it's that platform as a service where basically you deploy your code and you don't have to worry about any of the runtime, any patching, any things like that. That's all taken care of for you. When we start talking about functions, there is also a little bit there that functions now run inside of containers, so that you can actually do it in pretty much anywhere you want. But basically, we're going to be concentrating today on the PaaS services available in Azure. So the first thing we want to talk about is LogicApps. So coming from a BizTalk background, I think that the LogicApps are probably the closest thing that most people can see to BizTalk in Azure. And basically it's a workflow engine, and it's got the ability to connect to a lot of different things. There is also another offering that is very close to LogicApps in Microsoft, and that's the Power Automate, which that's the new name for it. Just a couple of months ago, it was renamed from Flow to Power Automate, and it's an Office 365 offering. So basically, you can get that access to that through your Office 365 subscription. And also it runs in kind of a isolated area inside of Office 365 to do work. It's kind of designed for that citizen integrator side of things to be able to create some integrations. There are tooling that will take a Power Automate and move that to a LogicApp, so that if you do build something that you want to use in your whole company, you can actually move that into a LogicApp. We're going to then look a bit at the designer, and then what's behind the designer to see what's there. We will look at some of the different connectors. So there's 200 odd connectors for LogicApps, which gives you a really easy way to get started with a lot of things. And we'll go through those connectors when we go into the demo in just a second. Where we can run the LogicApps. So the LogicApps run in their own environment. It's even kind of past the PaaS environment. You just go create a LogicApp and you can run that there. So there's no, like with a web app, you need to create a app service plan, things like that. With the functions, you need to create a function app, and that needs to either have a app service plan behind it or a consumption plan. But with the LogicApps, they have just released recently an offering for the integrated service environment, integration service environment, that will allow you to spin that up inside of your VNet so that you can have your LogicApps running inside of your own VNet. We'll talk a little bit more about that a little bit. For deploying those, we can either build them in the portal, or we can also build them in Visual Studio, which we'll look at, and then we can deploy them. They are deployed as an ARM template, and we'll talk a little bit about that when we get there. A couple of the features we'll look at in the demo is around how you run them. And one of the things that they've got built into the Logic app is a control of the concurrency. And also, if you get say a JSON object coming in that has an array at the top level, you can actually use the split on to basically split up and have multiple Logic apps process each one of the items that's in that array. You can also split further down in your document too if you've got another array in there, but you've got that control so that you don't have to try to split those up before you call the Logic app. The Logic app can do that for you. We'll look at some of the debugging, and we'll look at how we monitor the Logic apps. So let me hop into the first of the demos. And basically what I want to do is I've got a Logic app just getting ready to start here. So basically I've gone in, I've said I wanted to create a new Logic app. I've given it a name, I've given it a resource group. I've told it I want to use log analytics. So that's some of our logging capabilities. And you'll see here, I got a choice between region and integrated service environment. So basically I can hit review, and then I can hit create. That's going to go off and create that. And that'll take a second. So we're going to hop back over here to our Logic App Designer here. If we hop back to the Logic App itself, we'll see that we've got some run history. We've got information about the trigger it's using. But what I want to show mostly is the editing experience of the Logic App. So this is in the Logic App Designer in the Azure portal. You can see that I've set this one up already for a HTTP trigger. I can delete that and go here and basically pick from any of the connectors that we have. We can start here, and we can see that there are triggers for an immense number of things there. So there's even integration with Azure DevOps, a lot of different providers that are non-Microsoft. So we've got a lot of things there. Typically in this example, and what we're going to talk about with the APIs, is that we're going to process a HTTP request. We can give it a body. Let me just hop over to one of the other screens. And I'm going to grab a body that I've got set up into and what I can do is I want to use a sample payload to generate the schema. So if I paste in my sample schema, I can hit done, and that will actually create my JSON schema. And then basically that's what it's designed to accept. If we go here and look at the settings, this is where we can also do things like add custom tracking to it. We can also tell it that the inputs or outputs are secure. So if we're calling off to something that may be bringing back logons and passwords or critical information, we can suppress that information out of the logs. This is where we've got our concurrency control. So we can set our degree of parallelism. So we can say we only want one of these to happen at a time. And we also can turn on schema validation so that if the inbound request doesn't match our schema, then it can basically go there. And so let's go and just say done to that. And so you'll see that we now have, when I save this, it generated the URL, which is a fairly long URL to call. This is part of what we will talk about next week when we talk about API management to make this easier for people to use. But now that I've got my request in, I've got a choice here now of doing a lot of different actions to basically go out here and call off to different things. I could go down here, say service bus. I could write a message to send a message to a service bus queue. And what it's going to ask me for is all that information about the connection. I've got a connection set up in here. So I've got an inbound queue, and then I can set some properties. If I want to set system properties with the run details, things like that. In this particular case, I want to add a content type and content. And the content of the message is actually going to be the output of it's actually breaking that schema down. So we could just do a expression here that is our trigger body. And then the content type being application JSON. And then we save that. And then we would also probably want to respond back to it. And this is going to be our response. And then we can say whatever we want to in terms of that. Maybe we just want to give back a 200. And if we save that, let me go turn back off the concurrency control. I didn't mean to leave that on, but and that, and hit save. Okay, figure out why that is decided not to do that. And I don't think it's either one of those, but okay. So let's figure out what we've done. I should have, okay, I just didn't save that part. Okay, not being the way that I wanted to do this, but you get the idea. We've got another one that we'll do a little bit later on that we can finish up on that. But basically, we have, once we've got that done, and let's just discard that. We're back to our HTTP request that we've got there, and we can actually just add a really quick response to that.
Hey, Bill, just a quick one.
Yep.
When you have a moment there, if you could just zoom it in a touch as well,
Okay.
if possible, that'd be fantastic. And I've just had Anonymous put through a little tip. Apparently, if you click on Code View and then save, it'll save. It's sometimes a bit of a common UI bug. So.
Yep. So yep, it's doing the same thing
Anonymous.
there. So code view. So this is one of the things I wanted to show anyway. Is basically this is the code behind the designer. Now, it's not your regular programming language. It is JSON. So basically, we have our definition, and then we have basically our operations. And see, the concurrency stayed. So obviously they've got a interesting bug in that. No, didn't like me doing that either. Let's see. Let's discard that and figure out why that. See if it goes back to the designer. It's back to that. And that's already been saved. So let's go try that and just run that. It's probably going to fail because there's no schema passed to it. But what we can do is that I will show back in the designer in here. Let's do a refresh. And you can see we had one run there. The other thing I want to do is go in and go back into the editor, really quickly pick up the URL. And I'm not sure how many people have used VS Code, but basically we have the ability in VS Code to go in here and do a And I'll grab the same thing that I had there and just put the declaration in there and then paste that in. So that's basically VS Code being able to call that. So we'll do a send request. And then it got a 202 accepted because it didn't send anything back. So now then if we go back to here and then go back to our run history and do a refresh, we should see that run. And what we'll see is when we go in here to the debug side of it, we can see here's what the schema was, and we can see what the raw input was for that one. And then we can also see the output, and there's our output. And if we go and look at the one that I just did, we'll see that we've got a output, and there's the body that we sent to that request. So I don't know if people are familiar with, there used to be a tool that you could just send a web request to and see what it looked like, request bin. LogicApps is a really cheap and easy request bin to set up because basically you can just post anything to that and it'll show you the body that comes out of that. So, and then we also can have a quick look at our, go back to here and look at the dashboard and look at our, actually more items, log analytics, which is what the LogicApps sends the data to, and we can go in there and we've got the log analytics piece for LogicApps in there, and we'll actually, there's the solutions, LogicApps. So basically that will give us the summary of our LogicApp calls, except it does take a little while to catch up because it goes through the whole process. We'll have a look at the application insights connection in the Azure functions just a little bit later, and it's a little bit quicker on pulling that up, but we can come back to this a little bit later and have a look too. So let's go back to the slides. So we looked at basically how we look at the code that's behind the designer. We looked at some of the connectors. Again, there's 200 odd connectors, and we looked at a little bit of the debugging, and we'll follow up a little bit on that monitoring as we go. So there was our LogicApps. Now we're going to switch to functions. And now the interesting thing is that the big difference between LogicApps and functions is that functions are more like the code that we were used to writing for APIs and things like that, but with a lot of the plumbing gone, where LogicApps is that graphical designer where you click something and you just do some configuration. So it's, and I always remember a good friend of mine, Mitch Denny, one of the reasons he never liked BizTalk is he couldn't go into Notepad and write the code. So again, that's the difference between LogicApps and functions a bit, where functions you can pretty much do in any designer you want to. But again, we're going to look at the same type of things, the designer, what's behind it. A few of the connectors, there's not as many connectors for functions as there is for LogicApps. Where you can run, that's a big difference, and how you deploy, debugging, and monitoring. So let's go back into here. Let's go back into our browser, go to the dashboard, and go to our demo functions. And what I've got here is that I just got a function app that I've created. I didn't really want during the demo to have to wait till this created to come back to it. So I've got one HTTP trigger. This is just the out of the box HTTP trigger for your functions. And you'll see that when we look at the code, when it decides to refresh, let's just refresh it real quick. And again, if I'm building enterprise software with functions, I'm probably not going to be running the designer inside of the portal. I'll be doing it in Visual Studio, and we'll look at that in a moment. But basically, if I click on there, you'll see the code that, except it just does not want to show that code for today. So let's go and add another function. So that we can go here, we can add an HTTP trigger. We'll call it trigger2, hit create. And there we have code finally. So basically what you'll notice is that we only have our particular function. There's none of the other stuff that you would have with an API app. And we basically have a request coming in. We're doing some parsing on the query string. We're doing a read on the body. And then we're looking for some values. And then we're outputting a response. We've got a built-in test capabilities inside of the portal. And basically what we can do is we can pass it a value here, and it will just scroll over a little bit. We're passing it a value. So if I hit save on that, what we'll also see is down in the logs down here, it'll basically show you what's happening. And then I'm going to go here and do a run. And what we'll see is we've got a hello Azure, because basically it was able to parse out the body above and be able to bring that response back. And all of our logging also showed up. Actually, there is an issue sometimes where you need to clear and reconnect to the logging before it will actually show some of that. And let's run that again. There we go. We have some logging now. So basically, we have that C# trigger that was processed. I could go down here and do a log name, and then just save that. And then run that again. And we should see that that name comes out in our logging. Now, the good thing about the logging configuration is with the version 2 of the functions and version 3, you can now do a dependency injection. So you can inject your favorite logger. Also, when you deploy this to Azure, you can set up application insights to be able to get this logging information. And we'll look at that in just a little bit. But basically, everything behind this right now is right here in the files. So basically, it has 2 files. It has a function.json and which gives it the integration information. Let me try to get over to that. So that gives us the binding information about the HTTP trigger and what we're returning. And then the run.cx is the actual code file. And so basically that's what we need to run our functions. Now, if we go into something like Visual Studio, let's go into Visual Studio. And if I bring Visual Studio over, and this is a little bit small, let me zoom this in. So this is a similar function that does, and the difference is that you'll notice that when you create the Visual Studio Functions project, and then go create a function. So if I go here and I say add a new Azure function, and give it a name. I'm just going to give it function 3. Then it prompts me for what kind of trigger I want for it. So if I just HTTP trigger, you'll pretty much see exactly that same code that you saw in the portal just then. Just the difference being that it's in a functions.cs file. And Also, this means that if I've got some existing data models and things like that, I can use them easily into here and be able to do that. And the other nice thing I can do is I can actually run this in my local machine, which with LogicApps, I can't do local debugging. I need to be deployed to Azure. So if I do that, what happens is it starts the runtime. And when it's done loading up everything, you'll see that it gives us the 2 URLs for the functions that are there. And then what I can do is if I go to there, and then I've got this one right here, which is my local host, and I'll do a send request. And then we hop back to there. We can actually see in the logging in this window where I was able to run that locally. Now, the other thing is we can also, I'll just shut that down. There is also an option to create your function in a container and then basically use Docker Desktop on your development machine to basically push those images into the container and then run that container locally and do your testing locally, then deploy that container to, say, AKS in Azure. So,
love it, Bill. Hey, did you want to have a quick little break here? We've got a bunch of questions coming through from the crowd. They've done an awesome job, so thank you, everyone. I'm sure some of them will be, very opinionated. So I think they're a good one for you to ask you. Some of the differences between sort of Power Automate and LogicApps and when to use one over the other.
So Power Automate kind of runs in your own workspace in Office 365. So it's really not something that that you can actually share with the whole company. You could actually share in their Power Automate, but there is some restrictions on the amount of runtime you get depending on your Windows or your Office 3 or Microsoft 365 subscription. So with the Logic app, you deploy it into Azure and then basically pay for those per run costs that you do. So it's really more of how you want it managed. So if you have it in Azure, you're managing it with the rest of your Azure subscriptions. If you have it in Office 365, it's really more designed to do things for the particular person. So like one of my good friends in Canada had a Power Automate that was going and looking at his emails coming in over the weekend. If it was an email from his boss, he turned it into a text message with a Power Automate and sent a text to his phone.
Very, very wise move. Very wise move. There's another couple of questions that are coming through around how to manage version control for your objects. You care to sort of shed some light on that?
In terms of the functions, LogicApps, or both?
Yeah, well, let's go for both.
Okay, so with your objects in there, what I have been doing is I do my deployments and things like that with Azure DevOps. So what I do is for the LogicApps, I take and put the ARM template into source control, and then I do a build step. And you really don't need a build step for a function, but what you can accomplish by that is that you can validate the ARM template to make sure it's correct, and then you push the ARM template out as a build artifact, and then you have a release step that releases to your dev, test, UAT, prod environments. And that means that if you release one, it's broken, you can always go back and pick up the build artifact from the previous build, deploy that back out, and you get control of it there. The functions is pretty much the same way. Now, this is where next week's talk about API management really helps out, because you can have versions and revisions that you test with API management. And we'll talk a bit more about that next week in that session, but I tend to not really expose a lot of APIs via LogicApps or functions without using them behind API management. and that takes care of that control. But again, Azure DevOps being able to push those out as build artifacts and then be able to control it that way.
Fantastic. Maybe one more, because it'll be a quick one here from Nisha. Can we use LogicApps to trigger a failed backup in a hybrid environment?
You can run some PowerShell from that. The interesting thing is that you could also do it from functions, because one of the things that I haven't shown and we can look at is that, or actually we'll look at it a little bit later, but what we can do with functions is functions actually can be created in PowerShell. And what I mean by that is it can be a PowerShell function. So if you're a ops person that know the language you know best is PowerShell, you can have a function that's PowerShell. And then it can run those PowerShell commands you need to do. Just to give you an example, I was looking at one where when I do a build, I had a customer that was doing BizTalk. We needed our own custom build server. So I basically wrote a function that would go off and start up the BizTalk build server, wait for it to spin up, and then go back to the DevOps build, and then it would be ready to run my build. And then when it was finished doing the build, it would go run another function to shut the build server down. So basically, they didn't do that many builds. So having a build server running out there in Azure all the time was a waste of money. So we basically used that to start and stop those. So both LogicApps and functions have timer capabilities. So you can tell a Logic app to run every 5 minutes, every hour, every day. You can tell a function to do the same thing. So both of those are ways to do that. And also, they can also trigger off any kind of Azure Event Grid events. So.
Awesome, thanks. Guys, keep the questions coming, guys and girls,
Yep.
Sorry. Bill, I'll let you continue with your preso.
Yep.
Cheers.
So basically, implementing APIs. So APIs, we've kind of looked at this a little bit already, but we'll go back through a little bit of that. And the big thing that is different really kind of from doing an API in, say, a Visual Studio C# API project is that you can, it's really easy to bolt on the open API specifications or Swagger to your API. There are some ways to do it in the functions. There's not really a way to do it in your LogicApps. So again, this is why that next week's talk about API management is going to be essential, because you can produce that open API specification out of API management for both LogicApps and functions. So, and again, I'll hop into the LogicApp demo real quick, and just, actually that's not where I want to be. Sorry about that. Okay, so if I go back to here and go back to my resource group, go into my LogicApp, go into the editor. So we've got our HTTP request coming in, and say we want to go to a SQL server. So as part of the API, we're receiving our request, and we need to go to write that into SQL. We can go in here and we can search for SQL, and we can say SQL Server, and we can do the query. We can do and this is what typically I would do, is do a execute stored procedure, and then basically how you want to do the integration. I probably don't have a SQL Server setting out there that we can do that, but basically it's can use the AD authentication. I'll kill that for just a moment, but basically we could do that SQL Server to write into a stored proc. We could also go to just delete that. We could go and we can see that we have Cosmos. So we got Cosmos DB here. We can go in there and we can create or update a document in Cosmos and give it a connection name, just one, and pick out this one and say create. And then pick my database, which is my to-do list, and my collection ID, which is my items. And the document, it could be the body from my HTTP request. And then I could save that. So basically, that's going to go out there and run that request, and then go to Cosmos DB. So let me grab that workflow ID, hop into my REST client, and get rid of that, and just go here and make sure that's the right URL. I think it was the same there, and I'm going to go and give it a different ID, and then go here and do a send request. And again, I didn't return a response, but it got a 202 back from that. So if we go back to our Logic app and go here, we should see our run. There's our run. And then we go back to into our Cosmos DB, go into the Data Explorer. And there's our number 5, which has got our 5 and the rest of that information plus some Cosmos information into there. So that's about as hard as it gets in a Logic app to write something into Cosmos DB. And then we can return. That also could be a GET. This one particularly was a post, so we were posting data in, but we could do a GET and go out and do a query against Cosmos to basically come back with that the details about that execution. So we can pretty much, and I guess the one thing that I've actually seen people really using Logic Apps for is to extend their existing API. Say they've got a customer API deployed and they've got an order API deployed and a product API deployed, and they want to create a composition. So basically, I want to receive a document that has the customer information in it, has the product information in it, and wants to place an order. So what they could do, you could go through, you could basically call the customer API to verify the customer or to look up extra information about a customer. Then you go look at the product information to make sure that's correct, and then you would create the order call in your Logic app. So that's an easy way to basically use composition on your different APIs, where you really didn't want to introduce those dependencies in your code, but you could do that with Logic Apps to do that. So let's go back to the slides here. Questions about the Logic Apps and APIs?
Yeah, thanks, Bill. That was awesome. There are a couple of good questions. Let me just have a quick look through. Right, where are we at? There was one a little bit earlier. Could we just do like a quick cover of how you integrate GitHub, CI/CD, and DevSecOps? So where does this sort of fit within the pipeline tooling, and how you I guess you connect the dots? This was from Larry. Now it wasn't looking for anything too detailed, just more of a general how you would go about deploying via GitHub and how it integrates with DevSecOps.
Yeah, so with GitHub, you can connect GitHub to the Azure DevOps pipelines, or you could use the GitHub Actions. It's basically with the LogicApps, it's an ARM template. With the functions, it's a web app deployed into a function app, or a website kind of deployed into a function app. So that part of it it's probably a bigger discussion than we have time for right now on how that all hooks together. But basically, you can do the Azure deployments pretty much from any of the tools that are available out there, GitHub included, all the different the other different ones too, Octopus, Azure DevOps, things like that.
Fantastic, thanks. How does it relate to runtime management, so functional and non-functional failures, and does Azure offer any support for this sort of issue?
So both of them do, because basically what we have in our LogicApps, we can do a scope, and we can have a action execute if another action fails, and we can handle all of that. In terms of that, I'll try to look at that a little bit when we get into the integration side of it, and I can show you a little bit about that in the integration side. Let's have a quick demo of the function apps, because we're running out of time at the moment. So if we go back here and go back to our function app demo, we can see that we have our HTTP trigger. And so that's purely there. If you notice this integrate tab over here, this is where we can integrate with some of these other pieces. So if I want to add another output, I can go down here and I can pick from something like Cosmos DB again. And then basically what I've got to do is I've got to create the, get a connection string for that. And I basically give it my collection and my out database name. If I've got it in a partitioned thing, I can do there. And when I save that, which is probably going to complain about my connection string, but I'll try to keep this a little bit quicker. And then go back into our trigger. We would add that inside of our run. We would add that connection piece in there, and then it would allow us to, inside of our function app, to be able to do that same write to Cosmos DB. And again, you could do this yourself because you are setting in code, but you can also do it via the integration piece. And you'll see you could have multiples of those in there, and the connection string needs to be placed inside of the connection strings inside of the function app, and you can control those during your deployment process with DevOps and things like that. So let's hop back to the slide. Any questions on the function app side?
There was a question here on function apps. Can you use function apps to connect to an on-premise SQL server?
Yes and no. I will give a little.
Elaborate.
I will give a little bit more details. If your function app, if you have a connection to Azure, either a VPN connection or an express route connection into a VNet, you can set up a service connection between your VNet and the function app, and then that will allow you to call into your VNet, which then is connected to your on-premise database. So if the connection string is correct with like most likely IP address, because it's going to be hard for that name resolution to happen, you can do it. Now with LogicApps, there's a tool that was designed for Power BI, and it's called the on-premise data gateway. And so LogicApps can use the on-premise data gateway to get from Azure to the database inside of your environment through the on-premise data gateway. It's probably a bit simpler to use the on-premise data gateway from LogicApps than it is with all the VNet and the service connections and things like that.
Bill, I'll just jump in there. There's Shri here. There is also another way you can connect in using hybrid connection if you want to avoid the VNet, setting up the VNet and all this stuff.
Yep. So yeah, the hybrid connections have been around a while too, and they work that. What I've seen is it's actually as bad as it sounds, it's a little bit easier to do the VNet. But yeah, so there's a couple of different ways you could do that. And the other thing that we haven't talked too much about is that functions will run in containers. So you could run your function inside of your VNet in a container and expose it through the network security groups in your VNet so that people can call into the function running inside of your VNet, and that VNet's connected to your on-premise network. It could then call in to the SQL that way. The other option is if it's a internal service that you want to do, you could have the container running inside of your on-premises network, your function running in that container in your on-premise network, talking directly to that on-premise database. So there's a couple of different ways there that we can do that. That's why the answer is yes and no.
Awesome question, Anon. Thanks for that one. And
Yep.
It seems like there's a few different ways to solve that challenge. I'll just have a quick look. I'll see if there are any other really good ones. I think we've answered a couple in chat. Larry's got another great question here. Given the LogicApps has code that can be version controlled, obviously because you can import it from Notepad if you're clever. Does this mean you can port like an old integration platform into LogicApps via transformation? And is there an Azure tool that can port legacy integration to Azure LogicApps?
I haven't seen any tooling. There was some talk at one time of some guys were trying to build a piece that would take the BizTalk orchestrations and turn them into LogicApps. But both of the people that were thinking about doing that went to work for Microsoft, so that project kind of died. But the thing is that because it is JSON, you could write something that would convert your integrations into those JSON calls inside of a Logic app and deploy that. But I haven't seen anybody doing any of that at the moment.
Awesome, Larry. Hope that that answered your question. Larry's absolutely flying with these questions. So
okay, so let's quickly go into this. I'm just about out of time, but quickly on building integrations with both functions and LogicApps. So, and again, the big difference between an API is typically your integrations are working with like a file received or a message received or a state change instead of that REST call where it's a post. So if we look at the LogicApps for that, and just go here, oh, that's my window. Here, go back to here, go into our Logic app. I'm just going to use that same one. That way I don't have to wait for one to create. And what I'll do is I'm just going to delete both of those pieces. And what you can do now in the trigger side is I can say service bus, and when a message is received in a queue. Now this gets into a little bit of that talking about the error handling. So if I do a message receive in a queue with a peak lock, so basically go into there and let's see, the name of the queue should be inbound 1 and the queue type, and then how often I want to poll for that message. Now, you do get charged for each one of those polls, so be a little bit careful. If you are doing something where you just get very sporadic messages, you might want to look at Event Grid. So now I've got that, and basically, if I go in here now and go back into that Cosmos, create a document using that same connection, and then the document's going to be, let's see where I've got the service bus, oh, sorry, yeah, the content of the service bus message. Then what I can do is I can add 2 steps. I can add a service bus complete message in the queue. And so that basically, again, we go look at the queue. The lock token basically would have come from our piece there. And so that would automatically complete that message. What I could do is, if I wanted to, I could add another one in here that does a abandon. And so name of the queue, inbound, and then basically there's my lock token that I picked up before. And then what I can do is I can set this one to configure the run after. If the Cosmos DB has failed or it's timed out, I want to run that. And then basically this one would be a configure run after. If abandoned message is skipped, which means it didn't hit those criteria, then the complete message would run. And you could reverse those. So you can basically, in that case, basically what would happen if the write into Cosmos failed, the message in the service bus queue would get abandoned and it would try again. So that's one of the things that we could do in the way of processing those messages off of a queue. Let's just see how good my head up. And this is still having that same issue, and I see if I can figure out what that is causing that to do. So no, we're going to have to skip that real quick, figure out why that is done that when I made that one change before. But basically, I'll post something up on there a little bit later on that manual. Okay. So that's not going to cooperate. We can do a similar thing with our, let's hop back to the slides real quick and go through the, is there any questions about that? In that we also have a scope that we can put those abandoned or complete operations into. If we need to do several things, like maybe we want to abandon it and then we want to write some additional log records and we want to email somebody, we could do that in there also. Any other questions?
In the interest of time, we might just try and get to them at the end. So we've got about 5 minutes left. So
So in the function app, let's go in real quick and do a demo in that. And what I've actually got is in here in my code. I've already created one, and that is the function app 2. And what that is a service bus trigger. It's looking at that same service bus that I just picked out there. And I basically can set that up. I've got in my local settings, I've got the service bus connection string. And basically, if I spin this up in the container and then go out to the here and just go back to my home. I know it's going to complain about throwing that away. That's all right. And then into here, I've got a logic app that will just send some data to that service bus queue. So if we bring up, I'll just run that trigger a couple of times. And then if we go back out to our execution of the, and just bring up the window, which, okay, no, that's not it. Here it is. So basically, there are those 2 messages I sent to that function. It picked up those messages and processed whatever process we want to do on it. And one of the things I wanted to talk to you about on this one is that was running in my local machine. So I don't have to worry about trying to have an emulated version of Service Bus. I can actually connect to the Service Bus in the cloud from my local machine and process those messages that are waiting. So again, we've got a few different ones in the, that's that one, in the LogicApps are in the functions. We've got a few different connectors that we can use for our, that's not the one I wanted to go to, sorry, that one. So if we look here, we'll see that if we go to add a new function, we've got HTTP trigger, timer trigger, storage queue, service bus trigger, topic trigger, blob storage trigger, event hub trigger, Cosmos DB trigger, IoT hub, send grid, event grid, all these different triggers that we can use in our function app. Not as many as we have in LogicApps, but a fair few that we can use for. And the event grid is a really good trigger for a lot of the different events going on in Azure. Okay, let me just hop back to there. And I'll quickly go to my last slide. A little bit about the how to choose. So the LogicApps, what I tend to see is a lot more of the people that are used to using some of the existing integration technologies. So where you're doing little or no code, and it's a pure PaaS, it needs to run in Azure. It can run inside of an ISE, which is inside of a VNet. The only problem I have, and I know Cherie doesn't like me saying this, is that it's very, very expensive for what you get when it's running in an ISE for a consumption-based service. The difference with function apps, they're code. So if you've got developers that are used to writing C# code or any of the languages that functions are available in, they can just basically step right in. You can deploy them into the Azure PaaS, or you can deploy them into containers. And they'll run in the public Azure, they'll run inside of a VNet through an ASE, they'll run inside of a VNet through AKS, and they'll run anywhere else in containers. So that's really kind of the piece to that. The next is why serverless? So I know my background is a long way ago where you never could run anything without building a machine. Serverless is so much easier. I can spin something up in a few minutes. I can pay a consumption-based charge. I don't have to buy a virtual machine where I'm running it all the time or part of the time. It's I deploy it and I pay for my use. I did one for a customer where they were having trouble keeping websites alive, so they needed to ping them every 10 minutes. And we had 6 endpoints we needed to ping every 10 minutes, 24 hours a day, 7 days a week, and it cost $1.42 a month. So that's a really good kind of illustration of the cost of the serverless pieces. And again, LogicApps, if you don't want to do code, if you want to, you do have some limitations on what you can do because of the tasks that are there. There is a code block. It's in JavaScript though. So that's the only drawback to that code block. The Azure functions, you can pretty much do anything you want to. You could write your whole API architecture in functions. But again, both of the serverless offerings I've used a lot of times to augment existing APIs quickly and easily. So the next step is to go out and try them in your Azure subscription. You can get started with LogicApps as the Power Automate. You can also get started with the functions, basically consumption-based plan. You pay for what you use. A really easy way to get started, a really cheap way to get started.
That is awesome. Thank you so much, Bill. You're a superstar, mate. Really appreciate your time today. Everyone, thank you for joining us. You've been amazing and your questions have been absolutely fantastic as well. Please, I'll send out a survey at the end of this. Please feel free to respond. If anything else you want to see or ask Bill some more questions, just let us know. Otherwise, we will see you next week. Shri, did you have anything else you wanted to add?
No, all good. See you all next week.
Oh, good. Thanks, Bill, again.
Okay.
See you guys.
Thank you very much.
Have an awesome day. Bye-bye.
Thank you. Bye.